Right on. What's good, Logan? So today we're going to talk about how to solve right triangles and making sure that we understand what this is. So my suggestion, don't take notes, just kind of watch it. I'll go ahead and post the notes on Canvas so that if you wanted to write the notes down, you can. They'll be fully accessible, it'll be complete, whereas right now it's just kind of like the outline. Okay, so let's get into it. Solving triangles, what you're going to first do, or not even first do, the understanding is to solve a triangle is essentially to find the measure of all unknown sides and angles. So that's what we're going to be looking for, is we're going to try to find all the measures of all the unknown sides and angles when we're solving these triangles. Here's the technique very quickly. The first thing you're going to do is you're going to set up two things. You're going to set up a trig equation, all right, using the known side that they give you and the acute angle they give you. Now you're going to do this twice. The first time you're going to do it with one of the unknown sides. So you're going to use the known side and the acute angle and one of the unknown sides. Then you're going to set it up twice. You're going to set it up a second time. So you're going to do it again with the known side, the acute angle, and the other unknown side. Then after that, you're going to find the other acute angle using the angle sum theorem. So in essence, what you're trying to find here are three things. You're trying to find the first unknown side, the second unknown side, and then finally the other angle, the other acute angle. All right, so let's take a look at a couple of example problems, four example problems actually. So we're going to take a look at our first one, number one. This looks very similar to the homework. What you're going to do is you're going to have a triangle that's kind of given like this guy right here, and they're going to tell you some of the pieces of information, right? So in this problem, they're giving us angle B is 45 degrees and side C is 5. Just as a reminder, uppercase letters are going to represent angles. Notice the uppercase letters all represent the angles. And then the lowercase letters, like the C's over there and the A and the B over there, those all represent the lengths of the sides, not to get confused. So uppercase and lowercase do mean different things. So let's go ahead and set up the very first problem. It says that it says that angle B is 45 degrees. So what I'm going to do is I'm going to find where angle B is. Angle B happens to be right there. So in the top corner, I'm going to write a 45-degree angle there. So we'll put 45 degrees right there. And then we're going to say that side C is 5. Now C is the side also known as hypotenuse, so I'll put a 5 right there. Our job is now to find, right, as we go back in our notes, we're going to find two things. We're going to start off finding two things. All right, we're going to find the first unknown side, right? So we're going to do it twice. We're going to find the first unknown side, and then we're going to find the other one. Then after that, we're going to find the acute angle. So in this problem right here, I know that we have two sides that are unknown to us. The two sides are B and A. So I'm going to set up my trig function first using A or B, it doesn't really matter. I'm going to use A, and I'm also going to use the angle and the side that's known to us. So we're going to use the 45-degree angle on the other side that's known to us. Noticing that we have the hypotenuse here, we know that we can't use tangent. So we're going to use sine or cosine. So I'm going to set up my problem. I'm going to say that the hypotenuse goes in the denominator, and I'll put A on top. And then this is going to equal 45 degrees using either sine or cosine. Now, noticing that I'm using the A in this problem right here, the A right there, I know that the 45 degrees is adjacent. That A is adjacent to the 45 degrees. So I'm going to use cosine for this problem. So we'll write cosine of 45 degrees is equal to A over 5. That's the first equation. I also have to set up a second one, but I'll set up the second one after I solve this one here. So to solve this, I have to remember that cosine of 45 degrees is equal to the square root of 2 over 2. Remember, you're going to have to go back to your table and understand and just recall with those special angles that you have what cosine, sine, and tangent of the 30, 45, and 60-degree angles. So we're going to say that the square root of 2 over 2 is equal to 5. Now we're going to go ahead and solve this thing. I'm going to go ahead and solve it by multiplying both sides of our equation by 5. Sorry, I wrote A by 5 on the right side, the left side. On the right side, the 5's cancel out to 1, so we get A. So we have A is equal to, and then the 5 over here on the left side doesn't cancel with anything, so it's just going to be 5 root 2 over 2. So we found the first side. Now to solve the triangle, we need to find all the sides, all the unknown sides. So now that we found this one, we don't need to worry about that guy anymore. So you can put a check mark, or you know what? You could just erase it, and then you could write in 5 root 2 over 2. Now, I try not to use these new numbers because they're kind of ugly and they kind of get in the way. So what I'm going to do is I'm going to keep using the same numbers we had before, the 5 and the b. So now I set up my second equation. So we're going to use the 5, the hypotenuse, which means we're not using tangent. But since we've already used cosine, we kind of already know that we're not going to use sine on this one. We're not going to use cosine again. So we'll say sine of 45 degrees. One more time, that's the 45-degree angle. We're going to be using the b, which is the opposite leg. So we're going to write down b on top is equal to b over 5, the hypotenuse. Now, we know that sine of 45 degrees using our table is the square root of 2 over 2. If you haven't memorized that one yet, it's one of the easier ones because 45 degrees always yields root 2 over 2 for both sine and cosine. You'll notice you have the same exact equation. That kind of makes sense though because 45, 45, 90 is an isosceles triangle. We're going to go ahead and multiply both sides of our equation by 5, left side by 5, right side by 5. And it cancels on the right side. But on the left side, what we end up getting is 5 square root of 2 over 2. Nothing cancels. And we now have our second unknown side. So we'll go ahead and erase that guy over there, and we'll write down 5 root 2 over 2. We just have to find one more thing, and that is the other acute angle. That would be the angle that's right there. We need to find that guy. And we know that the angles of a triangle always add up to 180. Since one of those angles is already known to be 90 degrees, that means these two angles only have to add up to 90 because 90 degrees is already spoken for. So we're just going to take 90 degrees, subtract the 45 we already have, and we find out that the remaining angle is 45 degrees. So we'll go ahead and write that down over here. The 45-degree angle that we did not know, the 5 square root of 2 over 2, the side we didn't know, and the 5 square root of 2 over 2 that we didn't know as well. All right, moving on to question number 2. Now, you'll notice that on question number 2, the angle is 32 degrees. This usually means that we're going to need our calculator. So what I'm going to do is I'm going to go ahead and bust open. So I'm going to do split view. I'm going to bust open my calculator from Desmos. And I'm going to hit the wrench just to make sure that it's in radians. I'm going to switch it over to degrees. Now we're good to go. We can use that calculator anytime we need it. All right, let's go back to full screen over here. And we're going to input all the information. So we know that side A, or angle A, is 32 degrees. So it says it's 32 degrees. So I'm going to put a 32-degree symbol right there. We know that side B is 10. B is the bottom piece, so we'll put a 10 down there. And our job is now to find side A and side C. Now, if I want to find side A, that's not going to use the hypotenuse, then we are talking about tangent. So I'm going to go with that guy first. As soon as we can use tangent, I like using tangent right away. So we're going to say tangent of 32 degrees is, I always like to put the opposite one on top. That's how tangent works. And the adjacent one on the bottom. So we're going to go A, the opposite on top, over 10, the adjacent on the bottom. Now, tangent of 32, I don't have that one memorized, so I'm going to go ahead and open up my Desmos calculator, and we're going to, let's make sure, yeah, we're in degrees, and we're just going to go ahead and type in tangent, let's make sure, tangent of 32. So we'll type it in, go to functions, find the tangent function, and we'll just type in 32, and we get 6248, but it's going to round to 9, so we're going to say 0.6249 is equal to A over 10. Now we're going to go ahead and solve this equation by multiplying both sides of the problem by 10, left side, right side. We don't need a calculator on this guy because we know that when you multiply by 10, what ends up happening, it just moves the decimal. So we get 6249. So we now know that A is 6.249. If you want, you can erase that guy over there, fill it in with 6.249. All right, next, let's find C. So now C is the hypotenuse, so I'm going to use the hypotenuse and I'm going to use the adjacent leg. So the hypotenuse and the adjacent leg usually means we're using cosine here, so I'm going to write down cosine of 32 degrees is equal to, the hypotenuse goes in the denominator, and the adjacent leg goes on the top. All right, we have to go back to Desmos. We're going to type in cosine. So hit the function, find cosine, and we're going to do 32 degrees. That's going to give us 0.8480. So we'll write 0.8480 is equal to 10 over C. All right, so we're going to solve this guy here. Now we should be multiplying by C to get rid of that crazy denominator of a variable. So we'll multiply both sides by C. That gets the variable out of the denominator, but it does give us something really ugly. We get 0.8480 c is equal to 10. Now what we want to do is we want to isolate the c, dividing both sides by that ugly looking decimal. We'll divide by 0.8480 on both sides. I unfortunately, or fortunately, whatever you want to call it, don't know what that is, so I'm going to go to Desmos, and we're just going to type in 10 divided, let's go back, 10 divided by 0.8480. And this is going to give us 117925. We're going to round this one up, so I'm going to go 11.7925. So if we want, we can take the c, we can erase it, we don't need it, and we can write 11.9, sorry, my mistake, 7925. All right, so we've got all the sides. Now we just need to find the last angle. So we're going to identify what this angle is right here. Remember, since it's a right triangle, we already know 90 of those degrees of the 180. So I'm just going to go 90 degrees, take away the 32, and this is going to give us 58 degrees. So we know that this angle is 58 degrees. We've now solved the entire triangle. All right, let's move on to question number 3. We're going to do the same exact thing that we did on the last two problems. So let's fill in that triangle. Angle A is 71 degrees, side C is 20. So we'll write 71 degrees right here. We'll say side C is 20, and then we'll identify the other two sides, B and A. So we're going to find out what B and A are. Noticing that we're using the hypotenuse here, so I'm probably going to be using both sine and cosine. So I'm going to go ahead and say sine of 71 degrees is equal to, sine uses 20, the hypotenuse, in the denominator, and sine uses the opposite. So we're going to be using A for sine. So we're going to say sine of 71 is equal to A over 20. We're going to go to Desmos, and we're going to hit function, and then type in the sine of 71 degrees, which comes out to 0.94551. So it rounds to 55, which is equal to A over 20. We're going to go ahead and multiply both sides of our equation by that 20 to isolate the variable A. Right side by 20, left side by 20. Go to Desmos, and we're going to go 20 times the 0.94, that's not 0.9455, and that's giving us 18.91. So we have 18.91 is A, and we can go ahead and fix that into our triangle. So this guy right here is 18.91. All right, now we just have to find out what B is. Since we're using the hypotenuse, we know that it's not going to be tangent. We've already used sine, so go ahead and use cosine. So we're going to say cosine of 71 degrees is equal to, the hypotenuse goes in the denominator, and the adjacent leg is going to go in the numerator. So we're going to take that B, put it on top, and then we're going to solve this by taking out Desmos, typing in the cosine of 71 degrees, which is 0.3256. After we round, that's going to bump up to 5/6, and we get equals to B over 20. We're going to go in and solve this by multiplying both sides of our equation by the 20. Grab our calculator. So we go to Desmos, and we're going to type that in. So we're going to say 20 times 0.3256. And that gives us 6512. So we have 6.512. And that right there gives us our third side, or our second unknown side, 6.512. And then we just have to find the last angle. So we got to find that guy right there. We know that the angles always add up to 180, but since 90 degrees of it has been spoken for, we just take the 71 away from the 90, and we get 19. So we have a 19-degree angle chilling right in there. All right, moving on to the last question, and you guys can start on the homework. What we're going to do is we're going to solve our last triangle, triangle 4, where side B is 60 degrees. Let's go take a look at that triangle. What is it going to look like? So B is up in the top right-hand corner. So we'll put the 60 degrees up here. And then we also have the A is 7. So that's going to give us the 7 right here. B is right here. And C, the hypotenuse, is there. So the first thing I'm going to do is I'm going to do the one that doesn't use the hypotenuse. That's right, tangent. So I'm going to take the tangent of 60 degrees. So we take the tangent of 60 degrees, and that's going to equal the opposite of the 60 over the adjacent of the 60. So we're going to take the opposite leg, which is B, and put it over the adjacent leg, which is 7. So we're going to go opposite B over adjacent 7. All right, so we take out our table. 60 degrees is one of those special angles, and we know that tangent of 60 degrees is just the square root of 3. So we have square root of 3 is equal to B over 7. We're going to go ahead and solve this by multiplying both sides of our equation by that denominator of 7. Multiply it right, multiply it left, and we find out pretty quickly that in this problem, B is going to equal 7 square root 3. So we have 7 square root of 3 for our B. So we can erase that guy over here and write in 7 square roots of 3. All right, moving on to side C. So running out of space, I'm going to go ahead and scroll this guy up just a bit. So now that we've set that up, now we have to use the hypotenuse. So I'm going to use the hypotenuse, and I'm going to use the adjacent side, not the opposite, which has 7 square root 3, primarily because they gave us the 7, just in case I made a mistake on the 7 square root 3. So I always use the given information. So we're going to use the adjacent and the hypotenuse, which means cosine. So we're going to write cosine of 60 degrees is equal to, hypotenuse always goes in the denominator, and the adjacent leg goes in the numerator. We have to go to our table. Cosine of 60 degrees is 1 over 2, which is equal to 7 over c. Notice we didn't have to use decimals. Let's get rid of that guy. Go full screen on this. All right, so we have 1 over 2 is equal to 7 over c. I'm going to go ahead and cross multiply this one, just because 1 times c is c, so I get the c by itself, and 2 times 7 is 14. So I now know that the side c, or the hypotenuse, is 14. And then I have to find the last angle, the angle that's right there. And since there's a 60 and a 90, I know it's going to be a 30, 60, 90. All right, go ahead and try the assignment. I gone ahead and posted it on Canvas, and I will talk to you guys on Friday. And if I don't see you, have a great break, and see you guys when you get back.